Hi, welcome back to video 2 of our series on how to reduce your AI LLM costs. My name's Troy McGuinness, and let's get started. This video is on how to avoid identical repeated calls. So inside applications, when you start running them and you especially start watching production usage, what you will see is a lot of repeated calls. And often the cases are when they return to a previous page, so they dig in, they do an LLM call, they dig into the detail, then they hit the back button on the browser. And sometimes our pages reissue the LLM request with the new context or the same context. And I found that this was rampant. There was especially around where we had starting examples on our homepage or inside the application, there was, a quick summarize button. And it was the identical request every time. There were also sort of compulsive button clickers. They were a bit frustrated that it was taking 10 seconds to write a poem about cats and dogs, and they would click again and again and again. And then there was other cases where people were intentionally hitting the button multiple times or sending requests through other code as a denial of service attack, just to run up my credit card bill. Now, you've got a couple of choices here. One is that you save 100% of the cost of the calls you don't send. A Wayne Gretzky quote there, but variation thereof. But the job is to not send the request if you don't have to. Now, how do we do that? One is we use our application state and we disable the button once we've got a result, and we only re-enable it once context changes. So, what we do is we inhibit hitting the button multiple times. And the second one is that when we do get a result, we can cache the body that we sent to the LLM, the response we got from that body, keyed by the hash of that body. Because if the body hasn't changed, sure, LLM models are non-deterministic, so we would get a different result the second time. But for the purposes of our application, the first result is useful. Now, one tip there, just instantly returning the result also left the users a bit sort of frustrated, because they were expecting an LLM response to come in, and the previous time it streamed in nicely on the screen, and now all of a sudden they hit a button and bang, it's in their face. So one of the things we found, even if we return a cached response, we simulate streaming of that response so the user doesn't sort of get that jarring impact of an instant result where they didn't expect one. Now let me explain how to do the caching. Now, when we send an LLM response, what we really send is, there's a lot of header information, the API key, but the body contains everything that the post request to the API, the SDK being used. The body is what actually sets out the messages, the system instructions, and all of the other settings that are required. Now, if they're identical, when we're going to get a different response from the LLM, but the response we got last time is probably a good response. So what we sort of do is we take the request body that we would have sent, and we create an MD5 hash or whatever type of hash that you want on that body that we were going to call. So we take the stringified version of the request body and we get a cache key. Now we save that cache key, or we try and look it up, and if it's in our cache, what we do is we return that response instantly. Otherwise, we go and continue doing our fetch call, and then we add that result using the cache key that we had back into the into our cache, whether that's Redis or however we want to handle that. I store them in the database, we have them expire. Now, LLM as a service, our product, which is a gateway, does this automatically, and you can set the caching window, but you get the idea. The idea is that if the body hasn't changed and we've issued the call before, just return a result we got before. So with that, thank you. Again, this is series number 2, 100% of the savings for the calls you don't make, and I'll see you next time.